Let's differentiate now the function with respect to y. So we treat y as the variable of interest, x and z we treat as constants. So f derivative with respect to y. We differentiate every term with respect to y. So e to the power x plus y derivative with respect to y plus x squared times y derivative with respect to y plus z to the power of 3 derivative with respect to y minus y times z derivative with respect to y. So we have here e to a power, we keep it like that, but because the power is an expression, we differentiate the power itself because of the chain rule, plus x squared times y derivative with respect to y. We have a product, we said x squared is a constant, so we take the constant out, and y derivative is just 1, so we only leave the constant, plus z to the power of 3 derivative with respect to y, that's a constant derivative with respect to y, so it's just gonna be 0, and then minus y times z derivative with respect to y. Well, we have only the constant, which is z. Let's write it once again. So it's e to the power x plus y. X plus y derivative with respect to y is just 1 plus x squared minus z. So that would be the first partial derivative with respect to y. Let's do now the second partial derivatives, where we differentiate first y and then y again. So derivative with respect to y and one more derivative with respect to y. So we take the first partial derivative with respect to y, e to the power x plus y plus x squared minus z, and we differentiate this thing with respect to y once more. So the first term derivative with respect to y is e to the power x plus y times x plus y derivative with respect to y. X squared derivative with respect to y, that's a constant derivative with respect to y, so that's just 0. And z derivative with respect to y is again a constant derivative, so that's 0 one more time. Which means as a result we only have e to the power x plus y times 1, which is e to the power of x plus y only. Now let's do the derivative of y and then with respect to x. So we will need the first partial derivative with respect to y and then differentiate it one more time with respect to x. So y and then x, and that's equal to e to the power x plus y plus x squared minus z. That's the first partial derivative with respect to y. Differentiate with respect to x. So now x is the variable of interest, y and z are constants. From the first term we differentiate e to the power x plus y times the power derivative with respect to x plus x squared derivative with respect to x is 2x, z derivative with respect to x, that's a constant derivative with respect to x, so that's just 0. So we have e to the power x plus y times 1 from here, and then plus 2x, and that's gonna be it. And the last one is the derivative of y and then with respect to z, so y and one more time with z. That's the first derivative with respect to y, which is again e to the power x plus y plus x squared minus z derivative with respect to z. So we're treating z as the variable of interest, x and y are constants. So we have e to the power x plus y times x plus y derivative with respect to z plus x squared derivative with respect to z. It's a constant derivative, and that's going to be just 0. And z derivative with respect to z is just 1, so minus 1. What's the final result? Well, x plus y derivative with respect to z is going to be just 0. E to this power times 0 is going to give us 0. So as a result, we have just 0 plus 0 minus 1, which is minus 1. And that's it with these partial derivatives. In the next video, we'll finish it off with z.